Sprites are large-scale electrical discharges that occur high above thunderstorm clouds, or cumulonimbus, giving rise to a quite varied range of visual shapes flickering in the night sky. They are triggered by the discharges of positive lightning between an underlying thundercloud and the ground. Sprites appear as luminous reddish-orange flashes. They often occur in clusters within the altitude range 50–90 km above the Earth's surface. Sporadic visual reports of sprites go back at least to 1886, but they were first photographed on July 6, 1989 by scientists from the University of Minnesota and have subsequently been captured in video recordings many thousands of times. Sprites are sometimes inaccurately called upper atmospheric lightning. However, sprites are cold plasma phenomena that lack the hot channel temperatures of tropospheric lightning, so they are more akin to fluorescent tube discharges than to lightning discharges. History: allusions to transient optical phenomena above thunderclouds can be found in anecdotal reports from as early as 1730. Nobel laureate C.T.O. Wilson had suggested in 1925, on theoretical grounds, that electrical breakdown could occur in the upper atmosphere, and in 1956 witnessed what possibly could have been a sprite. They were first documented photographically on July 6, 1989 when scientists from the University of Minnesota, using a low-light video camera, accidentally captured the first image of what would subsequently become known as a sprite. Several years after their discovery they were named sprites after their elusive nature. Since their 1989 discovery, sprites have been imaged tens of thousands of times, from the ground, from aircraft and from space, and have become the subject of intensive investigations. Characteristics: sprites have been observed over North America, Central America, South America, Europe, Central Africa, Australia, the Sea of Japan and Asia and are believed to occur during most large thunderstorm systems. 3 types of sprites have been categorized by Matthew Jeff Machag Ph.D. of the U.S. Air Force Research Academy. Using an image intensifier on the front of super slow-motion camera, Machag and his researchers have named the sprites based on their visual appearance. Jellyfish sprite, very large, up to 30 by 30 miles. Carrot sprite, sea or column sprite. These are large-scale electrical discharges above the Earth that are still not totally understood. Sprites are colored reddish-orange in their upper regions, with bluish hanging tendrils below, and can be preceded by a reddish halo. They last longer than normal lower stratospheric discharges, which last typically a few milliseconds, and are triggered by the discharges of positive lightning between the thundercloud and the ground. They often occur in clusters of 2 or more, and typically span the altitude range 50 to 90 kilometers, with what appear to be tendrils hanging below, and branches reaching above. Optical imaging using a 10,000 frame per second high-speed camera shows that sprites are actually clusters of small, decometer-sized balls of ionization that are launched at an altitude of about 80 kilometers and then move downward at speeds of up to 10% the speed of light, followed a few milliseconds later by a separate set of upward-moving balls of ionization. Sprites may be horizontally displaced by up to 50 kilometers from the location of the underlying lightning strike, with a time delay following the lightning that is typically a few milliseconds, but on rare occasions may be up to 100 milliseconds. In order to film sprites from Earth, special conditions must be present: 150–500 kilometers of clear view to a powerful thunderstorm with positive lightning between cloud and ground, red-sensitive recording equipment, and a black and lit sky. Sprite halo: sprites are sometimes preceded, by about 1 millisecond, by a sprite halo, a pancake-shaped region of weak, transient optical emissions approximately 50 kilometers across and 10 kilometers thick. The halo is centered at about 70 kilometers altitude above the initiating lightning strike. These halos are thought to be produced by the same physical process that produces sprites, but for which the ionization is too weak to cross the threshold required for streamer formation. They are sometimes mistaken for elves, due to their visual similarity and short duration. Research carried out at Stanford University in 2000 indicates that, unlike sprites with bright vertical columnar structure, occurrence of sprite halos is not unusual in association with normal lightning discharges. Research in 2004 by scientists from Tohoku University found that very low-frequency emissions occur at the same time as the Sprite, indicating that a discharge within the cloud may generate the Sprites. Related aircraft damage, Sprites have been blamed for otherwise unexplained accidents involving high-altitude vehicular operations above thunderstorms. One example of this is the malfunction of a NASA stratospheric balloon launched on June 6, 1989 from Palestine, Texas. The balloon suffered an uncommanded payload release while flying at 120,000 feet over a thunderstorm near Graham, Texas. Months after the accident, an investigation concluded that a bolt of lightning traveling upward from the clouds provoked the incident. The attribution of the accident to a Sprite was made retroactively, since this term was not coined until late 1993. See also, aurora, Catatumbo lightning, cosmic ray visual phenomena. References. External links: Red Sprites and Blue Jets, a digital capture of the VHS video distributed in 1994 by the University of Alaska Fairbanks that popularized the terms. Red Sprites and Blue Jets webpage by University of Alaska Fairbanks, Ground and Balloon-Borne Observations of Sprites and Jets, Darwin Sprites 97 Space Physics Group, University of Otago. Sprites, Jets and TLE Pictures and Articles, Sprites in Europe, European Contributors Blog, Conmau, T. Stenbeck Nielsen, H.C. Machag, M.G. Hayland, R.K. Observation of blue Sprite spectra at 10,000 fps. Geophys. Res. Let 37, L138008. Bibcode, 2010 GeoOR L3713808 KDOI, 10.1029/2010 gallons 043739. Mysterious Sprite photographed by ISS astronaut, Big Pic, short professional bio of Drive. Jeff Machag, photography website Betapixel posted a link to a very rare and very clear photograph of a Sprite taken by photographer Mike Hollingshead. Article at photographer captures rare photograph of a Sprite with an aurora, at the edge of space. A NOVA program that examines the phenomenon of Sprites.